Hi, so we're back again. We're going to do another example in chapter 10. This one is a triangular prism, so it's a little different. It's a little harder to draw, so I want to show you that part and show you how to figure out the area. So I'll share the screen with you again. And here we go. Here's the problem in the book. It says find the surface area of the prism at the left. Here's the prism. And first step is to copy it. So I'm going to draw the prism here. Again, I'm going to start with the front panel. So I'm going to start with a rectangle. And then I'm going to draw the top. And I'm not going to draw all those dotted lines, but I am going to put that this is a right angle. And that this measurement is 5, this measurement is 12, that this measurement is 3, and this measurement is 13. And those are all in meters. I'll just mark one of them as meters. All right, and then we can work on the page. I'll get rid of the book again, and we'll see what we have. So we need to draw this thing out. So just like in the last one, where I drew the front and the side and the back and the other side in a row, I'm going to do the same thing here. I'm going to draw this front panel. This is 13 by 3. This is 13 by 3. And then wrapping around in this direction, the panel that is underneath this 12, the back side of this thing, the side that's over here that I have a dotted line. If I had a dotted line, it'd be that panel. So that has a length of 12 with that same height of 3. So that's 12 here. And then if I come around this shorter square side, underneath the 5, this last piece over here to get us back to the front, is connected by this same line again. So here's the same 5, or there's the same 3 rather. And then this is a length of 5. All right, and this is still a height of 3. And this triangle has to go in somewhere. Now, the book tends to put it here exactly where you see it. I like to put the right angle here because when we go to make these, I think you'll have an easier time doing a right angle than an angle back. So this edge here would be attached to this edge. And the 5 has to go next to this side. So if we were to actually cut this and fold it up, this and this would be the same. And here's the 13. So here's 5. And this is the 13 that matches this side. And this is the 12 that matches this side. And then to do the bottom, we could do exactly the same thing. So what I'm trying to make here are figures that when you try to cut them out, you can actually make that shape out of it. Now, I'm not measuring here, but when you're cutting out, you probably should measure. But I'm trying to get a visual here. All right, and then we're going to figure out the surface area of all of these pieces, and there are 1, 2, 3, 4, 5 pieces. So this piece is 3 by 13, that's 39. This piece is 3 by 12, that's 36. This piece is 3 by 5, that's 15. This piece is 5 by 12, 5 by 12, here's your right angle, 5 by 12, and it's half of that, except there's another one over here, right? So the two triangles add up to an entire rectangle that would be the same as 5 by 12, which is 60. All right, so we have to add the areas up. We have 39, we have 36, we have 15, and we have 60. I didn't do this before, so let's see, bear with me. 60 and 39 is 99. Add 36 to that, that's 135. Add 15 to that, that's going to be 150. 150 meters squared. All right, and we'll come back with an explanation on Pythagorean theorem. I'm actually going to relate it to that problem right there. And then, because we didn't cover that well last time. And then I'm also going to show you a little bit about creating nets and actually making some of these figures. Okay. And